First of all, it's super exciting to be here in this panel, moderating the panel, and talking about how we can leverage spaceborne Earth observations to drive actionable climate insights. I think the focus here, and what we'll talk about in the panel, is on actionable, on use cases. So my name is Tamar Moise. By profession, I'm an Earth scientist. And it's amazing to have followed the evolution and the growth of the Earth observation domain from a time when at one time it was select, government-only satellite launches and instrumentation going up, data mostly used by researchers, to the state of affairs that we have today, where we have hundreds of commercial satellites alongside the government and public satellites. We have a multitude of companies working on the data, ownership from people across the globe, and multiple and ever-growing commercial use cases. So within the panel, as I said, we're going to focus a little bit on advances, on the use case in the domain. We'll touch upon the challenges for greater use and for still untapped applications, how to overcome the challenges, and possibly we'll talk a little bit about investments. So we're lucky to have great panelists and leaders in the field with us. Apologies ahead because of the delay, one of our speakers is not with us. And again, what's nice about our speakers is each one has a unique position along the value chain. And this value chain, if we look at the sort of two edges or the two extremes, we have the launch of satellites and data acquisition. At the very end, we have the processing of this data, lots and lots of data. So the processing and the translation of this data to something that can be used on the ground. So super happy to have with us our panelists. And I'll begin according to the order here. So we have Tamar Shekel with us, who is product manager at Google Research. And as we'll see, Google is an aggregator and processor of data, and Tamar will tell us a lot more about this afterwards. So they're using the data either directly for the end user or as platforms for other downstream users. We have with us Jasmin Inbar, VP of Corporate Development at Asterra, using third-party data, again, to provide actionable insights to multiple clients. And here, very happy to have with us on screen from the UK, we have Dan Osrin, who is UK Space Lead at PwC Strategy. And Dan provides support, services, expertise to different types of stakeholders and users in the value chain. So maybe we'll start first. I'll just go over to our panelists, and if each of them give a very short intro to the activities of their organization and what they're doing. We'll try and keep it short because you'll have plenty of time to discuss more later. So, Tamar, over to you.
Hi. Okay. So hi, I'm Tamar Shekel. I'm a product manager lead in the area of AI innovations for Earth observation and satellite imagery in Google, and I work very closely with a lot of our climate research in Google. And probably a lot of folks kind of wonder what is Google doing here, and because we are mostly known for Google Search, maybe Android, Chrome, the internet ecosystem. But our work is much more comprehensive than that. Probably most of you know about Google Maps, and that has been using satellite imagery, aerial imagery for a while to actually really create the maps, or at least some pieces of those. But climate, beyond map making, climate is really the kind of some of our biggest challenges we are facing as a society, and this will only go worse over time. And in Google, that makes it really high priority for us. So what we are focusing in Google in that area is really on both AI research, products, platforms that can help consumers, companies, governments to better address climate change, build resilience to its impact. And we think that there's a really big urgency right now, and we need a big solution. We need it now, and we feel that AI actually is one of the big catalyzers that will help us bring those big solutions forward.
Okay. Dan, as you're sitting there on screen, maybe we'll ask you to introduce yourself now.
Shalom, everybody. I actually can't believe how big I am, that everyone gets to stare at me, and any movement I make, you're going to be watching and spying on me. Really good to be here. So, Dan, I help lead the UK space team at PwC. Hopefully, you've all heard of PwC, but we're a large professional services organization, and we play a really exciting role in the space sector, but it's multifold. One, we're working with our clients in different sectors, financial services, energy, real estate, better understand what the opportunity is from satellite data and how to use it in their business. So that's one. Two is we provide professional services to companies in the space sector, so helping them actually package and monetize new data propositions and get them out into the market. So that's the second. The third is we work with our investor clients all over the world to help them understand new opportunities to deploy capital and helping them understand what does it mean to invest in space, where are there exciting companies and opportunities. And then the fourth is we work with our government clients on how to glue this ecosystem together in new policy, new funding programs, and initiatives that they can put in place to help drive the use of Earth observation data across the world. So really excited to be here and to share perspectives on this important topic.
Super, Dan. Thanks for being with us. Jasmin, would you like to introduce?
Sure. So hi, everyone. I'm Jasmin Inbar. I'm in charge of the Earth observation activities and corporate development out of Asterra. Asterra is a leading Earth observation company providing soil moisture insight to diverse sectors, including water utilities, infrastructure companies, and government agencies. What we do is we leverage synthetic aperture radars satellites that are equipped with a very special band called L-band. This is the only band that provides ground penetration and are able to extract information from beneath the surface. We are very active all across the globe, working in more than 65 countries worldwide, detecting water leakages, saving water, and also providing soil moisture mapping to, as I mentioned, to many sectors out there.
Great. So happy we're all here. So I thought we'd start off sort of zooming out a little bit at the beginning and talking about some of the advances and enablers that have led to this sort of growth in commercial satellites and use of satellite data. And at the same time, also seeing how this has impacted the evolvement of your business. I think at the beginning, I'm going to ask Dan, before asking you a little bit about your clients, maybe you can just give us a little overview on how you feel in general about how, the enablers and how this domain has grown in the last, say, decade or even less.
Yeah, of course. So look, Earth observation has been used for many, many, many years, decades, right? And the two oldest use cases in the book, which hopefully you will know about, is one, national security, and the other is weather. We all get weather alerts and applications and insights from the use of satellites. So those have typically been satellites from government organizations, and they've owned the data, they've launched the satellites. And actually, if you look at a curve of Earth observation satellites, you'll see a massive spike from 2017, okay? And it's actually quite staggering. And the majority of this spike was from commercial satellites. So what's happened? So Elon Musk and his SpaceX business created something called reusable launch. And if you've heard of the Falcon rocket, he basically got one of his rockets to take off, put satellites in orbit, and then land back on Earth. And suddenly he was able to reuse these rockets again and again. And this had a dramatic impact on the price of actually putting something into space. So we saw a cost decline. We saw the size of satellites, which used to be the size of school buses, then fridges. Now you can fit many of these Earth observation satellites in your hand. So the cost to get something up went down. The size of the assets got smaller. And so we've seen a huge range of commercial enterprise taking advantage of this and putting up new constellations. And we've had the growth of Planet Labs, Maxar, Spire, and many other companies putting up major constellations. And then there's the whole wave of what we can do with the data. And we've got better at processing data, storing data. Hopefully we'll talk about the buzzword Gen AI in a little bit too. But we've got better at dealing with all this data. And what it is collecting incredible insights on the Earth. So new generation of satellites, better at collecting and doing things with the data, and hopefully we'll talk a bit more about how it's being used around the world.
Super. Thanks so much for that sort of overview. And I think that leads us straight on, Tamar, to Shekel, over to you. You sort of discussed the issue of data and the processing of data. So, Tamar, Google, you sort of gave a little bit of the background, and we know that Google basically is making information accessible to all. But can you tell us a little bit about Google's journey into sort of Earth observation and the climate space specifically?
Yeah, sure. So, it started really, I think as I mentioned before, that, Google Maps, in order to build those kind of products at a global scale and also keep the data up to fresh, it was clearly, we realized that we have to start using satellite imagery, aerial imagery, that allows to get to this scale. But, three things happened, and, I think Dan was kind of highlighting some of those, that in the more recent years, not really recent, but more recent years, there's been really an explosion of Earth observation data coming, both in the amount of data, the diversity of the data, the quality, and that kind of really enables many more use cases. It also kind of makes it more ripe for disruption by AI. The second thing is, climate change, is the defining threat of our generation probably. And that is first really important to our users. And it's also really important for our, Google employees, our leadership. And lastly is AI. I think since 2016, Google has been an AI-first company. And we really think that AI is the key way that we can really achieve transformation and impact in our mission. So kind of taking all of these things together, we decided that we really should invest more in this space and try to lead the way on how to use AI in this intersection of Earth observation and climate change. So I'll give you one example that is kind of really surprising and it's also really, really impactful. So there's after, when airplanes fly, sometimes behind them they leave those white trails. Those are called contrails. And contrails are responsible for about a third of the aviation industry global warming impact. So our team in Google Research, they've taken data from satellites and built a model to try to detect where are contrails forming. Then they took data about flight patterns, the flight path of airplanes, weather data, and then built a model that is trying to forecast where contrails might appear after a flight or during a flight. Then we partnered with Breakthrough Energies and American Airlines, and we took 70 live flights where we provided the outputs of our models to the pilots and asked them to come to try to avoid the contrails. And after the flight happened, we looked again at satellite imagery and Earth observation data to kind of assess, okay, what kind of impact did that have? And what we saw is that first, they were able to reduce the contrails by more than 50%. And second, that was really, really encouraging, in order to do that, they only need to change their elevation by a few thousand feet, which is something that they usually do just to avoid turbulence. So, in order to really reduce the global warming impact of the aviation industry, there's many, many more things that need to happen. Investment in electric airplanes, biofuels, hydrogen fuels. And those things can take decades to actually materialize. But in this case, by combining AI, Earth observation, and satellite imagery, we're able to find a solution that can actually impact a third of the overall global warming impact of the aviation industry in something that could scale actually in years, not decades.
Wow, so I think that's really fascinating. As an atmospheric scientist, I loved reading about that research on the contrails. And I think it's amazing to see what the sort of data analytics can do, the immediate impact, as you say. And I think we also see here a big collaborative event, how you work together in order to reduce immediately. So that's great to hear about sort of Google's work in that. Jasmin, maybe we'll go over to you and you can tell us a little bit. You work on the one hand with a single variable, which you taught us about, and yet it has so many multi-users, as I was talking to you beforehand, just understanding your different sort of client base and the needs. So maybe you could tell us a little bit about the market drivers as well and the needs for your variable.
Sure. So as everyone here mentioned, we are swimming in data. There's no doubt about that. And the important thing, I think, or we think at Asterra, is to extract the relevant insights to the users. We need to understand what's important to them, what is their need, what is their pain, and based on that, to deliver them with actionable insights. At Asterra, we managed to crack, in a way, the strategy from bottom up. We understood, it wasn't that quickly, but we understood the pain and we decided to manage it in a very intuitive and simple manner. So for our users, for instance, they hardly don't care if the insights that they received was, were taken from an optical satellite, a synthetic aperture radar, SAR satellite, at what resolution, what revisit time. They have a problem to solve, and we are responsible to deliver it in a very, very intuitive and simple manner. When it comes to who are the users and who can benefit from what we are doing, so water, where it shouldn't be, is the number one reason for infrastructure failure. And this is exactly what we are looking for this weak point, for the signature of water, where it shouldn't be. So when it comes to leak detection, we work with the water utilities. Up until now, we managed to identify more than 120,000 leaks all across the globe, saving more than 500 billion gallons of water, so you can understand the impact and, of course, the energy that we managed to save as a result. When it comes to the soil moisture mapping, as it's a subterranean soil moisture, very accurate, precise map, this has opened up many verticals to Asterra in critical infrastructure sector. So if it's transportation to prevent sinkholes, railway, mining, flood management, you name it. Very busy.
So really multiple use cases just around soil moisture. That's fascinating. Dan, over to you. So as a consultancy, again, you sort of laid out at the beginning your different types of clients, but you work alongside multiple stakeholder types. Can you elaborate a little on your clients' climate needs and how Earth observations can tap in and help them solve some of their problems and needs?
Yeah, so look, I mean, Earth observation is actually responsible for collecting about half of all the climate variables that are important in the world, which is quite staggering. And if you think what imagery from satellites is doing, I guess three things. You've got just third-party transparency in what's going on the ground. You've got continuous monitoring of a site or an area, and you can detect change. So what this means, I mean, we usually talk about it from a climate perspective in three buckets. We've got climate risk, biodiversity, and then emissions reporting, but huge applications across all three. And maybe I'll give you a couple of examples. So for climate risk, we're seeing an increasing prevalence of natural disasters, flooding, fire, drought all around the world. So with satellites, you can look at variables that might be contributing towards that. So if you take fire, you might be able to see vegetation, actually how dry is the soil, where there might be fire breaks, what type of roofing you have. And so if you're doing risk analysis, you can use satellite imagery to understand potential variables at an asset level. So think really good for insurance, for example. You can also look after events have happened. So if there has been a drought, you can actually see the impact on crops, on pests, etc. If there's been a fire, you can see the damage to buildings. So it also helps with us responding to natural disasters around the world. So pre and post event, we call it. So that's a bit on the climate risk side. Biodiversity, a lot of banks and organizations are having to show that they can have a positive impact on nature with new products and projects. So now, rather than sending somebody to go look at each site and see actually how many trees were planted, the growth in green space, you can do this remotely. And it's actually amazing. If you put into ChatGPT, if you give it some satellite images, you can ask it what percentage of this image is green space, is trees, is water. You can actually monitor that over many different images and look at how green space is changing over time. So for example, in the mining sector, once you're finished doing all of your mining activities, you want to restore nature and vegetation. And you can use satellite imagery to prove over time the impact that you've been having. So that's an example for biodiversity. And the last one might be for emissions, where we're now getting really good at looking at different types of greenhouse emissions coming out of big industrial facilities. So for oil and gas, for example, there's a process called flaring where they're letting methane out of the chimneys and out of oil and gas facilities. We can pick this up via satellites. So suddenly for oil and gas trying to clean up what they're doing, they're having third-party companies saying, hey, we saw what you just did there. We saw the methane coming from your you're building, you need to clean it up. So across the climate and biodiversity spectrum, there's tons of opportunities, and we're seeing pressure from regulators, from customers. And if I give one just quick analogy, at the moment for financial services who need to report on biodiversity and emissions, they're having companies self-disclose how they're doing. They're self-disclosing on emissions or on biodiversity, etc. And so you can imagine their reporting level is here, but they're not getting everything. Right? We know that the actual emissions is probably higher than what everybody is reporting. So you have actuals, let's say, is up here. And what satellite imagery is going to do is going to provide better accuracy of the actuals that makes the reported go up. So we're going to be in this funny world where everyone is taking action to be cleaner. So you'd think the reported is going to go down, but the accuracy we get from satellites means it's actually going to go up. And if that makes sense to you, we're in a really interesting paradigm now with reporting as we get real data on what's going on the ground rather than companies self-reporting what they think is happening.
Wow, I think that's a really super important point, that we're really having much more accuracy and transparency, that we're not going to have this sort of bottom-up reporting, but we can also have the top-down really sort of visual. And everything will be much more open as to what's really happening and what has to be done. So that sort of leads the way to those actionable insights.
And maybe can I quickly add one other point? Because for all different use cases of satellite imagery, there's a whole ecosystem of different companies that will look at the same data, but a slightly different use case. And this is something fascinating for us to crack. So if you think of fire and looking at fire risk and how it's evolving, you have firefighters who are looking at this to actually send in firefighters and help sit with safety. You've got public policy and officials looking at where do you have fire breaks, how do we manage vegetation better. We've got insurance who's trying to reduce the risk of portfolios to forest fire. You've got people dealing with the nature credit market who's looking to value different sites. And you've got real estate where prices are falling in California where you've got real risk of fire. All these organizations are looking at the same kind of data, but to do different things. And I think that's a really exciting opportunity for the ecosystem, just to connect these different models, business models up.
Super interesting. And I think the whole issue of data accessibility and how your clients or others find the correct data and the right platforms that can actually give them what is required to make that decision making is a whole other issue. Maybe we'll touch upon that now, a little bit about sort of the value chain, the data processing, linkages between different players, and maybe collaborations. So, Tamar, maybe well, over to you again. You have a role of both data acquisition, but also you process data and you package it in various ways for whoever the end customer or user may be. Maybe you can tell us a little bit about your data, how you deal with the data.
Yeah, so I think Google actually have a few roles in this space. You know, again, like Dan was kind of like preparing for my answer. That was great. So first, you know, we are a consumer company. We have multiple billion users products that people come to every day for their information needs. And that means that we have a privilege and responsibility to make sure that they get the information they need at high accuracy, fresh. And when it comes to climate, that means things like, okay, how to avoid disasters, how to adapt to climate change, how to reduce my personal emissions. And so that kind of then translates back to your question, how we now need to process the data and how do we kind of bring it out. So for example, wildfires, which was just raised before, you know, consumers want to know where those are happening and how do I avoid them. So again, using Earth observation data, and then building on top of that kind of training machine learning models, we built something, a model that can actually use satellite imagery to track almost in real time the boundaries of wildfires around the world. And now we take this information and, you know, given we have those surfaces to get to the consumer and they are coming to us asking those questions, we can show them real-time information of where the wildfires are, whether it's in Google Maps or in search, in order kind of to guide them while they're in the context where they're looking for this information. But we are not just a consumer company, we're also a platform company. And there we kind of play slightly different roles. So Google Earth Engine is a platform for geospatial analysis. It's focusing on planetary sustainability and climate resilience. And it's been used for over a decade for, you know, thousands of scientific papers by scientists and academic institutions. all focusing around the climate, not just climate sustainability and beyond. And what made or makes this platform really unique is first it has large, fresh catalog of publicly available satellite imagery. It is also a computing platform for geospatial data and remote sensing data, or kind of Earth observation data. And also it's a kind of a collaborative platform for you both to create your products, whether it's like maps, insights, analytics, and then also share it back to the community. Now, originally it was developed for researchers that were using it, or for nonprofits mostly. And kind of we played really a role of both bring the data in and allow organizations to kind of act upon it. But I would say now is the significantly more interest from companies, from governments, we really need to kind of upgrade it and kind of move it kind of to more like an enterprise grade. So what we did, we connected it with the cloud, Google's cloud compute platform. We think like Vertex AI, which is where our AI development platform, or BigQuery, which is our data warehouse platform. And that kind of allows, to kind of connect seamlessly those components. Then if I'll take again an example from Dan about floods, an insurance company. If you're an insurance company and you want to know that when a major flood hits, you want to, as quickly as you can, to know how is that affecting the assets, under my responsibility. So you can train a model in Vertex AI, in our cloud platform. Then when the disaster hits, you take, as soon as possible, the fresh imagery available in Earth Engine, apply the model on those to get the extent of the flood, kind of where the area that were impacted by the flood. And then you take this data, import it into BigQuery. There maybe you have all your assets and the properties of those assets to get a very quick understanding of the impact the current flood just had on the assets you have. So this is just an example, although real-world example. And we are really kind of excited to see kind of how, through this connection of those kind of platforms together, we can allow the ecosystem in general to innovate. So in here, we really play a role more of a platform, bring data together, and obviously kind of bring the tools to allow innovation on top of it.
Cool. So it's really nice to see the dual role, that some of your products are actually for a direct end user, and others are enabling platforms and enabling further analysis.
Right.
I'm going to go over to you, Jasmin, and I'm actually going to go over, I'm going to ask you a few questions, because I see by the clock, I think we've been shortened a little, we don't have that much time. So on the one hand, if you'd like to talk more also about sort of how you can work horizontally, about collaborations of different people, different sort of players in the space who you may work with. But as we don't have that much time, if you'd also like to talk a little bit, touch upon some of the challenges, and maybe the challenges that you feel as a company in this domain. So, take your choice of what you'd like to elaborate on.
So I am a true believer in collaborations. And if I take the example of the floods, so if you will apply Asterra's subsurface soil moisture mapping and, before to see which areas are vulnerable, you'll have a great risk analysis for before the flood happens. So this is one way that we can collaborate. And we have great partners. You mentioned working horizontally. This is exactly what we are doing. We partner with data providers, with platform providers, and of course with insight/application companies. Sometimes we combine two technologies to solve better a problem. Sometimes we just provide a layer of insight and don't even know what is going to be the use for it. I mean, there's different ways. When it comes to challenges, so many times the challenge is, to teach or to kind of change someone's culture and to adapt Earth observation data. And to neglect current ways of monitoring. In our core business, things are done mainly manually, but we managed to handle it. We cracked it, and we now fully understand our customers and end users. I would say that our main challenge right now is data. So unlike many companies that don't know what to do with the data, and how to extract the relevant insights, we know exactly what to do. We need more data since we are using very specific satellites. But this can be mitigated because we are going to launch our own satellite, a commercial L-band satellite, which I'm sure is going to open more verticals, more market to Asterra, and going to enable us to provide our customers with more frequent results, since we're working in a software or satellite as a service model.
Wow, amazing to hear that you're launching your own satellites. And if I recall, when we were speaking, that will allow you not just a higher frequency, but a whole sort of different
Critical
area
time-critical applications.
Yeah, so
Yes.
that's like a really moving into another space, which is exciting. We're more or less, according to the clock, have to sort of wrap up. So I'm going to ask both Dan and Tamar also, maybe each one of you 1 minute, main challenge, main opportunity that you see in this field. Dan, maybe sort of closing words on challenges and opportunities.
Yeah, I think as an industry, we've got to become easier to buy from and easier to use, and do it in a way that end users are used to using data. So we need to prove that there's confidence around supply. The company and the data will be here for a long time, so you can build a product and it will last. History, it's got a track record. We can show it's been successful. Accuracy, we've ground truthed it. We've proven that it works. This is a new data source for many, so you have to get them over the initial confidence hurdle. And accessibility in the way that they want to use it and need to use it. And it's still a relatively nascent industry, innovating very quickly. So how do we become easier for users to actually buy and consume this data will be really important.
Super. And Tamar?
Yeah, so I'll maybe focus the opportunity and the challenge kind of the same thing, and you'll not be surprised, that it will be on AI. So I think in the last 2 years, I'd say there's been a lot of interest in AI, and that's kind of a summarization of maybe 20 or more years of foundational research in this space, and that now created some transformative experiences that people really got excited about. Now, beyond the hype around chatbots, I think in Google, we've been opening that space for many, many years, and it's really integrating everything we do, products like everyday product like search, but also some of the examples I gave you before around climate. So I think a lot of the opportunities are in this space of connecting AI, Earth observation data together to kind of, to fuel the next transformation and new innovations. But one of the biggest challenges, I think, in that space right now, that company like Asterra actually solved, and others, and that's where you can become, I think, more successful, is getting ground truth data to train those models. So Earth observation, kind of what we are working on, it's about the real world. And because of the real world, you sometimes actually need to be there on the ground to measure the depth of the flood, or maybe to find what's that species versus another one, or maybe find a coffee plantation that is below a thick forest canopy. So those things, kind of getting this data from the ground is kind of one of the biggest barriers and challenges. But when you figure that one out, I think it actually really unlocks a lot of differentiation capabilities in this space.
Cool. And I think if we're talking about sort of ground truth data, with all the applications of AI, and again, the AI has to be worked on here. Engineering has to be worked on how to make this accessible to different people and different users. In the end, I think it's so important that sort of the engineers and the data analytics are still working also with the remote sensing people, the people who have expertise in the field. So this sort of black box of AI that's working on all the data actually brings out results which we know can be sort of validated and usable, accurate, as Dan was talking about, the accuracy. So we're still nascent. I think this is a really, really exciting field where there are so many still untapped use cases, and I'm sure the field will grow. So I'd like to just thank our 3 panelists, Dan, Tamar, Jasmin, for being here and sharing with everybody a little bit about the space. Thank you.